welcome everyone to this session. I appreciate your time. I appreciate your willingness to come to reInvent this year. As I mentioned earlier, it's a great time to be involved with AWS. I've been with AWS for a little over 5 years now, and it's great to see the growth year after year, and it's great to see just the size of reInvent that we have this year. So I do really appreciate everyone being here today. So my name is Daryl Osborne, and I'm a storage specialist, solutions architect. So this session on WordPress is going to be leaning more towards the storage side, because that's really what sets this architecture apart, is how do we create WordPress so that it's stateless, where you move the data, both on the database side as well as the file system side, outside of the web server, so that we can take advantage of some of the elasticity of AWS. Meaning, how do we take advantage of auto-scaling groups, where you can scale from maybe just 2 instances up to 100 instances for your WordPress site? So we're going to be going into that architecture today. And we're going to be diving into each of the different components that make up a reference architecture that we have published. And soon we'll be releasing an updated white paper that also has some best practices for running WordPress in a highly available, highly scalable environment. So when you think of WordPress, what do you think of? We're going to go into that first. We're going to look at, okay, what is WordPress? Who's using it? Why do you want to use it? We'll talk about some of the requirements. We'll talk about aligning those requirements with the AWS features and AWS services. We'll also talk about how do we deploy it and how do we maintain it. So who's running WordPress today? I'm hoping everyone here. That's why we're here today, right? Okay, good. So WordPress, open source blogging, content management application based on PHP and MySQL, as I'm sure you all know. It's the engine behind many blogs out there today, both personal as well as some very high traffic corporate sites. So the latest version, 4.8, used by approximately 58% of the known CMS sites today. And I think as of February of this year, of the top 10 million websites, it's a little over, it powers a little over a quarter of those sites. So definitely a platform and application that is well used. So B2 Cafe Log, who's familiar with this? All right, so I think we're all familiar with it. We just don't know about it. It's one of those applications or platforms, the most maybe used platform that is unknown. In 2001, it was really the basis for WordPress. So it actually came out in 2001. It branched off in 2003, and that's where WordPress came from. So even though you may not know that you're using sort of B2 Cafe sort of in the background or what it used to be, you're using some of the roots of that platform. WordPress really released, the first version released in 2003. It was designed really pre-cloud. So it's not designed to take advantage of some of the elasticity, the scalability, the sort of this distributed architecture that we find ourselves using in the cloud. We're in the environment where we don't hug our servers. We don't hug our database server. We don't hug our web server. We really want stateless environments where a web server can go down and we don't care about it. We don't want to name them. We just want it to be available. We want that service to be highly available and highly durable. We also want it to be able to scale. And one of the advantages of AWS is we're able to do that. But what we need to do is take this architecture that was designed pre-cloud and carve it up so that we can create a stateless environment. So, when you're about to launch and create a WordPress environment, what are some of the requirements? So who's your audience? Is this an internal site where you're just supporting some internal groups? Or is this an external site? If it is external, where are your end users? What is the SLA for this application? What are the durability requirements? What are the scalability requirements? Do you see the need for automatically scaling out to a large number of web servers, going from maybe a few 100 requests or visitors to tens of hundreds or thousands, tens of thousands of users within just a matter of minutes? So these are some of the things you want to think about when you first start designing your WordPress environment. So while there are solutions out there today to run WordPress on a single instance, we're not going to be talking about this today. So this is really where you can run WordPress on light sail, single instance where, say, everything is running on that one server. We're really going beyond that. We're going from a single server environment to a multi-server environment where we don't want to be dependent on a single instance. So while it is possible, we don't want to go there today. And there are a number of other applications. There are applications built on Lambdas to create a serverless WordPress environment. There are solutions in the marketplace to provide this as really as a turnkey solution to get WordPress up and running very quickly. But again, there are limited scalability features of solutions like that. So really depending on what your needs are, there's a solution out there on AWS for your WordPress environment. But today, we're really going to be focusing in on the highly scalable, highly available, highly durable solution. So now that we know sort of what our requirements are, we know that we want a highly scalable, highly durable, elastic WordPress solution. Let's go ahead and look at how do we get there. So again, I mentioned this is going to be more centered around the storage side. So when you think of storage, you really think of, well, what are the different storage solutions out there, and which one do we want to take advantage of when we deploy WordPress? You want to take a look at their features, their performance, and you also want to take a look at the economics. Am I able to run this environment within the budget allotted to me? So when you think about storage, there's really three types. There's file, block, and object. So we're going to get into all three here in a couple minutes, actually right now. So file storage is really what WordPress is looking for. It wants a file system. Natively, it's looking for a file system to store its data file, its WordPress installation files. File storage is really a hierarchical view of files. Each file really has the data and the metadata all combined. It is natively stored in a file system format. And you can think of it more of a network-attached storage. That's a little different, really, compared to block. So block storage is really a disk or a set of disks that where the data is really stored directly on chunks or blocks. And an operating system would then take that, and you would sort of install a file system on that, and it would store its file system files within on this block device. Typically, it's a locally attached drive or disk. And then we have object. So most of us are familiar with Amazon S3, sort of that object store for the cloud. It's really designed, it's really a container for these objects where typically you have, HTTP requests, sort of web APIs in order to get access to this data, where you would put and get data from a cloud storage. It's really not intended to have a sort of a file system put in front of it. There are solutions out there where you can sort of have a pseudo file system in front of S3. But again, it still is object store in the background. So why is file system storage so popular? Well, it works natively with operating systems. Again, a lot of operating systems today, they take advantage, they need a file system. It provides shared access to the files within the file system, and there's a hierarchical sort of namespace. So very easy to work with, very easy to to maintain. When you take a look at how the three sort of compare in terms of throughput and latency, block typically has the lowest latency of the three. It is local to the instance or to the server. But then as the latency goes out, file has a little higher throughput where, with an EFS file system, you're able to get gigabytes and gigabytes per second throughput. But the latency is a little higher than, say, EBS or block storage because the data is actually durably stored across multiple storage servers, across multiple availability zones within that region. So it has high availability and high durability, but it comes with a cost, and that cost is slightly higher latency per file system operation when you compare it to, say, an EBS volume. And then we have object. So really the highest latency of all three, but you can get a lot of throughput, where you can have multiple, thousands and thousands of clients connecting to that bucket to getting access to those objects. So prior to EFS, how did we do it? How did we have a network file system available to all of our instances, in this case WordPress, so that we could create a stateless environment, get that file system storage outside of the instance onto its own sort of platform? So what we needed to do is really run it ourselves. We needed to have our WordPress clients connect to a file server, which would be an EC2 instance. That EC2 instance would have multiple EBS volumes attached to it. And then for high availability, what would we have to do? Again, if you just take a look at AZ1, this isn't the best practice. This isn't well architected. We would have to have another file server in another AZ for high availability and durability of your data. That EC2 instance would have, again, multiple EBS volumes. And then you have to have some type of replication between the two to make sure that your data is going to be consistent. So doing it yourself prior to EFS, while possible, it was still a challenge. But now we have EFS. So EFS is a fully managed, simple, scalable, elastic file system in the cloud. When we designed EFS, our core tenets were to make it simple, elastic, and scalable, all on a foundation of high durability and high availability. So why is it simple? Well, it's simple because there's no hardware to maintain. There's no storage to maintain. There's no network layer. There's no file layer. It just works. You create a file system within seconds, and now you can mount your WordPress servers, instances, to that file system and get access, shared access, to that data set. In this case, the WordPress installation files. It's also simple in pricing. There's a single price per gigabyte per month. You don't have to worry about, there's no upfront costs. There's no request charges. There's no other charges associated with EFS. It's a simple gigabyte per month cost. It's elastic, meaning that this file system automatically grows and shrinks as you add and remove files. So again, you don't have to worry about, am I going to run out of storage? You won't run out of storage. It will continue to grow and grow as you continue to add data, and it will shrink as you remove that data. And you only pay for the data that you're storing in your file system. And it's scalable. So it's scalable to petabytes of capacity. You will have, really throughput is based on the size of your file system, and you will have low latency, consistent access to that file system, regardless of the size of the file system. And it supports thousands of concurrent NFS connections. So all of this is really built on this foundation of high availability and durability. And your data is stored across an unconstrained number of storage servers in multiple availability zones, which really gives you the ability to have an AZ. In the event that an AZ were to go down and your data is stored within that region, you would still have access to the data in EFS. It is production ready. For production tier 0 applications, EFS is ready to take on those workloads. So it's designed to really support a vast array or spectrum of applications and workloads. Anywhere from big data analytics workloads, where you need high levels of parallelism, a lot of different threads accessing that file system, as well as very high levels of throughput, all the way down to single instance, web serving, low latency access to that workload. So the security model for EFS is this. You really control access to your file system via the network, where it supports regular VPC security groups and network echoes within your VPC. So you can control what security group or what IP or range of IP addresses will have access to that file system. We are POSIX permissions compliant. So if you're using POSIX permissions today, you'll be able to use EFS. On the control side for the administration of an EFS file system, it's all done through IAM users and roles. So that will give you the ability to create and maintain file systems, delete file systems, create and maintain mount targets. We'll get into what mount targets are. You can tag instances and you can delete. So all of that is done through the console or API using IAM permissions. And you can also create an encrypted file system when you create that file system. So actually, you can identify that this file system is encrypted when you create it. And it uses AWS KMS as sort of the key management to encrypt that file system. So the economics, again, very easy, no minimum commitments or upfront costs. No need to provision additional storage. Very easy. There's a cost per gigabyte month. And it varies in each region because our costs in each region vary somewhat. But again, there's no other cost associated with EFS. So again, we already saw this diagram, but before EFS, what did we have to do? We needed to support these Amazon EC2 instances, and we had to have the cost associated with those instances. We had to have the cost of the EBS volumes, regardless if we used the volume or not. If the volume was created and attached to that instance, you're going to be paying for that EBS volume. And you also have to maintain that intra-AZ or inter-AZ communication, where now that data that you're replicating from one AZ to another, there's going to be a sort of an inter-AZ cost associated with that. So very quick example, if you try to do it yourself for 500 gigabytes, you would typically see around a 70% cost reduction than trying to do it yourself. When you're really comparing EC2 instances that you need to maintain, the EBS volumes that you need to have and that AZ to AZ traffic. So EFS is available in 6 regions today, and we are aggressive, and we want to get out to all the regions, and we will soon. So now that we have sort of a base understanding of EFS and the distributed nature of EFS, and really we want to use EFS to create our web servers as stateless web servers. We want to move those files off of that web server onto a very highly available, highly durable platform. And that's going to be EFS. So by moving your WordPress installation directory over to EFS and mounting it on each WordPress instance, really your website automatically becomes stateless, because just the way that the core WordPress environment is created, it's looking for that file system. But if that file system is actually stored off instance, that instance can go up and down, and it really doesn't matter. Your data is going to be consistent, and it's going to be available to other instances because it's going to be connected to multiple instances within your WordPress fleet. So now that we sort of talked about the file system side, we wanted to sort of move the WordPress installation files over to EFS. Now we're going to talk about the database. Again, we need to make sure that the database and the database data is off the instance. We don't want it sitting on an EC2 instance. We want it sitting it on a highly available, highly durable platform. In this example, in this reference architecture, we want to move it off to Amazon RDS. Specifically, we want to move it over to Amazon Aurora. So Amazon Aurora is a MySQL-compatible database engine, relational database engine, that really increases the MySQL performance and availability because it's really tightly integrated with the engine and really a purpose-built SSD storage environment just for Aurora. Your data is actually stored, 6 times? 6 copies of your data is stored across 3 availability zones. So it's really designed for greater than 4 nines of availability. And it continuously backs up your data to S3. So by moving the database tier for your WordPress application over to Amazon Aurora, you're increasing the availability and durability of your WordPress site. Also with Aurora, the failover is automatically handled by the Aurora service. So your application can resume database activity automatically and really as quickly as possible. Now, what we do recommend is have a replica of your Aurora environment. This really reduces the recoverability to about a minute, where now the replica can take over the primary database operations, and we'll be able to now start serving up database requests very quickly, within a minute, versus if you didn't have a replica, it would take maybe about 15 minutes to recover from a failure. So we strongly recommend that. Now, we also see in this diagram a caching layer, a database caching layer. So we recommend Elasticache, and what that does for read-heavy applications and workloads like WordPress, having a database caching tier in front of the database really offloads some of the read activity so that the database is really there to take all of the reads, or sorry, take all of the writes. So if your application, so in this case, WordPress natively doesn't support Elasticache, so you'd have to install some plugins, a plugin. One plugin, just as an example, S3 Total Cache, is a plugin that does support some of the AWS services. So you could install that plugin and take advantage of Elasticache in that environment. So now if we move on to the web tier, again, we've offloaded the database data and the file system data. So now the only thing that's really, this web server is completely stateless. And really one of the characteristics of, say, session data is that session data for WordPress is stored where? On the cookie, on the client side. Unless you install third-party plugins, which may then alter that session information a little different, but the core WordPress installation, that session data is stored in the cookie on the client side. So that allows us to say, okay, there is no session data, there is no state being stored on this instance. So now we're able to take advantage of auto-scaling. We're able to scale up and down. We want to make sure that we drain those connections within the auto-scaling group so that we don't, so we have a good experience for all of our customers connected to the WordPress site. But it allows us to seamlessly scale up and down. One feature we do recommend, or a tool that we recommend for using EFS as the file system storage for WordPress is OP Cache. Okay, so OP Cache is a bytecode caching mechanism that is, as you know, when PHP scripts are executed and compiled, there is sort of a lot of activity going on sort of on the file system. So we're actually able to cache that on the instance itself using OP Cache. We're able to offload some of those metadata intensive operations and really have a better experience for the end user. So we strongly recommend, if you're using PHP 5.5 and above, take advantage of OP Cache and install that and configure it. So actually, as a part of the reference architecture, we have a CloudFormation template, really a set of nested CloudFormation templates that will create this entire environment for you, including OP Cache and an OP Cache monitor that will display the cache being used for each individual instance within your auto-scaling group sitting behind your Elastic Load Balancer. Also in this environment, if you see, within the reference architecture, we have sort of a bastion host. All of the web servers are not sitting in a public subnet. The only thing sitting in a public subnet is the Elastic Load Balancer. So our web servers, our WordPress servers, are all have private IPs. And they're accessed via the Elastic Load Balancer. If you need to get administrative access to that environment, there's a Bastion auto-scaling group. By default, within the CloudFormation template, it's set to 0. Just go ahead and change that. A Bastion host will go ahead and get installed, or will launch. You can then SSH into that, and from that, basically a jump host, SSH into some of your other WordPress servers within your environment. We do recommend application load balancer. We want to be able to take advantage of that versus the traditional or classic ELB that was really the original service. We do recommend ALBs, the application load balancers. And then finally, on the caching layer. So we want to take advantage of the edge network that AWS has. So we want to say, some of the content, static or dynamic, we want to be able to, try to cache as much as we can up at the edge, closer to our end user, so they can have a better experience. So take advantage of CloudFront. We have, 100 edge locations as of October, and we continue to add new and new edge locations around the world. So this just allows you to have, origin files, some of the media files that you want to serve up to your customers, closer to that end user customer as it's going to be served from the edge location. So how do you deploy it? Let's go ahead and take a look at this. Let me click through this first. So what's the size of your team? Are you doing this? Is there just you? Is this a DevOps environment where you're basically doing the development, operating, and maintaining this environment? Or do you have different organizations, different groups maintaining each section? Do you have DBAs? Do you have network administrators? Do you have file system administrators? So that's really where you want to get this down. Today, most people are run in sort of a DevOps environment. It would be nice to have a team of, say, 10 people or 5 people maintaining environments and having responsibility for each tier. But really, we don't see that today. We see that one person is responsible for everything. So that one person has to really be an expert on all these different tiers, and that's very difficult. So if we can automate and actually have those tiers in a managed service, it makes for a very easy DevOps experience for those users, for those administrators. Do you want it to be repeatable? Meaning that do you want to basically script out your environment so you can execute it in any VPC or in any region or any environment, production, dev, QA, staging, and have it consistent in each environment? So really, scripting out your infrastructure is ideal when you have a very small team and you need to maintain this yourself. Because as we all know, trying to manually set this up, that is a scalable, highly available, highly durable environment, is very difficult. So we encourage everyone to really script out your environment and use CloudFormation. The reference architecture that we have, all based on CloudFormation templates, you have a lot of different parameters that you can use in order to set this up. So let's go ahead and hop over to our reference architecture. Excellent. Is that big enough? Should I increase the size? How's that? Is that better? Okay, good. My eyes are going good, or going bad too, so it's good to see something a little bigger. So if you actually go to GitHub, AWS Labs, what is it? AWS-refarch-WordPress, you will be able to have access to this set of CloudFormation templates. Here it's very simple to launch an environment. We can go ahead and launch, in this case, in US West 2 in Oregon. It'll automatically pop up. It'll take us to the right region. Click on Next, and now we're going to see the different parameters included in this CloudFormation template. So again, we can select the key pair that's going to be used for the EC2 instances. You can have SSH access to the bastion host to a particular IP address or a range. You can also identify if you want to have an encrypted file system or not. If you do, you can optionally put in a KMS, CMK, or custom master key so that that file system would be encrypted. You then select the database parameters. So if you want to, this is going to automatically launch an Amazon Aurora cluster. So you would put in your database username and password, the database name. You can also optionally identify or select if you want to have a cache cluster, basically an Elasticache cluster. If you want to select that, you can go ahead and select the size of the cluster. Do you want to have a medium or what? You have lots of different options on the size of your Elasticache cluster. And again, that's going to launch in multiple availability zones. When we take a look at the web tier, we can also look at, do we want to create a record set in Route 53? If we have our own domain name and we want to sort of we want to create external DNS routes, it will automatically do that for you as a part of the CloudFormation template. CloudFront as well. So if you want to use a CDN, which is our CloudFront service, you can also elect that, and it will create a distribution with an origin of the actual Amazon EFS file system through your web servers, your WordPress servers, so that it will cache that data in these edge locations, so it's sort of a better experience. Now, again, out of the box, WordPress doesn't support CloudFront, but by using plugins, S3 Total Cache is one, you can actually set it up where it will allow you to take advantage of CloudFront and cache some of these files closer to the end user. Then on the, if you have certificates, you can also put those in for CloudFront, as well as for the ALB, the Elastic Load Balancer. That's going to be automatically created as a part of this. The web tier. So you can select the instance size of what instance you want to run for your web tier, and then the configuration of your auto-scaling group, the max and min size. In this example, we're just going to do a 4 and a 2. Then you go into the WordPress parameters, identify what the admin username and password is, the email address associated with that, the site directory, the domain if you have a custom domain name. Now, if you put in you need to have a domain name entered here if you select true for your record set, and it'll create that record set for you. Once you have that, go ahead and click through next, 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 and then bang. Within 20 minutes, you'll actually have an entire WordPress environment set up. So here's an example of one that I actually created this morning. We have our master template, and it actually launches all of these nested templates based on the parameters that I selected. Once that's up and running, you can actually click on the outputs of the master template, and you get access to the WordPress site. We can see that we're coming from CloudFront. If we go down, we can log into this. Let me make that a little bigger for you. There we go. Go ahead and log in. Hopefully, I'll remember my password. So now we're in. Very good experience again. So this is all of these. The WordPress installation files are sitting on EFS. All the database data is sitting in Amazon Aurora. So really, the only thing these web servers are doing is really forwarding this information over. If we take a look at, so in here, one of the great things of having the WordPress installation files on a sort of off the instance is that it allows us to easily manage plugins and themes. So for instance, what we could do is very quickly change the theme. Go ahead and activate this theme. Looks like that's already there. We can go ahead and take a look at that site. And now if we continue to do refresh, we know that all of these servers are actually serving up that data from EFS. Now, how do we know how many instances are actually behind this? If you go back to CloudFormation, we have our OP cache validation URL. Now, if we click on that, we can see that I actually included the instance ID here, so we know that when we do a refresh on this, that instance ID should continue to change. So we know that at least we have a couple of instances, 2 instances, within this auto-scaling group. So we know that when we do refreshes of our WordPress site, we're actually being served, it's coming from 2 different web servers or WordPress servers. So to easily scale our environment, what we could do is actually go into EC2, go to our auto-scaling group. Again, I mentioned that we have an auto-scaling group for the Bastion environment as well as the WordPress web servers. So these are identified. This is the Bastion ASG, and this is the WordPress ASG. We can look that we have a max of 4 and a min of 2 and a desired of 2. We can go ahead and change that. Let's change that to 4. Now, would you want to do this manually? Probably not. But what you can do is actually set up an environment where, based on the number of connections, or maybe based on the CPU of your web servers, your WordPress servers, it could automatically add new instances to the auto-scaling group. They will automatically be added to the ALB. So as soon as those instances have passed validation, they will then start serving up some of the content from EFS. And again, you can automate all of this. So really, it doesn't matter if there's 100 users accessing your site, or if it jumps up to tens of thousands of users. Your environment can, based on your parameters, your environment can grow in order to serve up this information to your users. So now if we go back to our instances, let's see if our instances are actually starting to launch. So it looks like we now have 4 WordPress servers running. 2 of them are sort of in the initialization phase. So give it a couple of minutes. We can still go back to our website. Oops. And we can sit there and click on this all day, and it's going to give us the same data. If we actually go back to the dashboard, I'm not a big fan of this theme. I like the new theme, so I'll just go ahead and go back. Again, you can do all of this easily, and you don't have to do it per instance. You do it once, and it's available to all of the instances within your fleet. We can refresh this, and all that data is being served up. Let's go ahead and take a look at this, see if these are actually available yet. If we refresh this, I think we're a little early. We're still probably only going to have, so we now have 3. So we have 504, we've got B6, we have DA, and we have 1E. So now we've got 4 instances within our auto-scaling group serving up data. If we change that back from a desired 4 to a desired 2, it would wait to successfully drain those connections off of those instances. Once those are drained, they will automatically terminate those instances, and now you're back down to 2. So again, very easy way to automatically scale your environment. Also, when you think of, so that's the web tier. On the EFS side, again, you have a petabyte scale file system. You're not going to run out of data. You're not going to run out of storage. So it doesn't really matter how much data you put in. It's automatically going to scale up. And it's going to scale down, so you don't have to worry about sort of maintaining that system. On the database side, you have Aurora. Again, automatically scale. SSD performance. It's really you have the best tiers available in your entire environment. So with that, let's go ahead and jump back to the presentation. So we already did this. We already went through. So that is, if you want to see the URL again for our reference architecture, it's github/weblab/aws.refarch, or aws-refarch-WordPress. Now, you don't have to run those CloudFormation templates as is. They're available there within the templates folder. Go ahead and download. You can customize it yourself. They are available for all the different regions that EFS is in. So it has all sort of the AMI mapping. But again, they're there for you to use, to modify, to customize for your environment. Take recommendations or sort of tricks that you see within those environments, within those CloudFormation templates, to build out your environment for your needs. So now that we have our highly available, highly elastic, highly durable WordPress environment, how do you maintain it? So how do you back it up? And how do you deploy plugins? So we do have an EFS to EFS backup solution. It's a project that we have up on the site. If you just Google EFS to EFS backup AWS, it'll pop up. It's actually a set of CloudFormation templates where you back up one EFS file system to another EFS file system, and it creates the environment for you. Basically, this design, this diagram here, it will create that for you within this environment. So easy way to back up your file system so you can have sort of a consistent backup of your file system. Maybe something you want to do before you deploy plugins or make any major changes to your environment. You want to make sure that you have a backup on all the different tiers so that if you needed to, you could really revert back to an older version. So managing plugins and themes, we already walked through this demo. Very easy to really change the theme. If you wanted to add plugins, you can go in and add a plugin as well. Again, that plugin is going to really be installed on EFS, depending on the plugin. Some plugins may make schema changes to the database. So you want to make sure that maybe you have a backup of your database as well before you install plugins. But again, none of those themes are really going to be installed on the instance itself because the WordPress installation files are being stored on EFS. So some of the best practices. Here is a big picture of what that architecture looks like. Everywhere from Route 53, hosting your DNS names, through CloudFront, on into your VPC, through all the different tiers, all the way down to Amazon EFS, which is storing your file system and your WordPress installation files. So again, this design and this diagram is available to you on that reference architecture page. So as I mentioned, we have a WordPress white paper that is very, very close to being released. We thought it was going to be released before reInvent, but it'll be released very soon. So look for that. That will have actually both types of solutions. It'll have sort of the single server, single instance solution using Lightsail, but it also gets into this reference architecture and goes into a little bit more details on all the different components and some of the best practices and recommendations. So look for that here in the next few weeks or so. So again, some of the best practices as we wrap up. Use CloudFront really to cache both static and dynamic content closer to your end users, taking advantage of those 100 edge locations so that your end users will have a better experience accessing your site. Use Elasticache to cache some of those database reads. So that'll offload some of that activity off of the Aurora, Amazon Aurora environment and cache that within Elasticache. OP-Cache, put OP-Cache, well, if you actually deploy this environment, OP-Cache is installed, configured using the CloudFormation template. But if you want to do it yourself, we do recommend OP-Cache if you're going to be using EFS. Just that ability to cache PHP scripts that have already been executed and compiled really helps the performance of your site. And this goes really for any PHP application. So Drupal and other applications that are PHP-based. If you're using EFS, we do strongly recommend that you use OP-Cache. Yeah, we already talked about EFS, shared file system. Now, the performance of EFS is really based on, when I say performance, I mean throughput and IOPS, is really based on the size of the file system. So keep that in mind. If your file system is very small, you may not have the performance that your site needs in order to sustain normal activity. The baseline throughput of an EFS file system is 50 megabytes per second per terabyte of data stored. So how many WordPress environments have a terabyte of data stored in their file system? Probably not that many. So then it converts down to 50 kilobytes per second per gigabyte of data stored. Well, now you're sort of doing that calculation. How many gigabytes is my WordPress environment? Is it 3 or 5 gigabytes? So now you're getting 150 kilobytes per second. May not be enough to sustain your site. So now what you need to do is you need to understand a little bit more about EFS and how we designed it for spiky workloads. So we understand that network file systems are spiky in nature. So for a very short duration of time, you're going to have high needs of throughput. Then for the rest of the time, it's really good. You're going to have low really a low need of sort of average throughput. So we built in a bursting model for throughput. So you're actually able to burst double your baseline throughput for short durations of time. And again, this is all based on the size of the file system. So maybe you can get 100 kilobytes per second per gigabyte of data stored. So again, if you do that calculation and it's still not enough, some of the customers that we've talked to that are running WordPress on EFS will just put in some dummy data. They will DD data and actually have a CloudFormation template I've got a tutorial out there as well, that you can create an EFS file system, and you can tell it, I want it to be 500 megabytes, or I want it to be a terabyte in size, and it'll automatically dummy data and put in that file system for you. So when it's done, you'll have a file system that is able to achieve maybe 100 megabytes or 200 megabytes per second throughput right out of the gate. So that allows you to really sort of, before turning your site over to a production environment, you're able to achieve the throughput you need in order to sustain your application. So just another something that you can do to sort of, that's not built in the reference architecture, that's something you have to do sort of after the fact. But I do have a separate CloudFormation template that you can do for an existing file system. It will automatically add dummy data to a directory and sort of do it for you. So just one thing to sort of to help out. Set up CloudWatch alarms. So what I could do too very quickly is I can, let me hop over here. I could take a look at some of the CloudWatch alarms that I set up that I monitor for my EFS file systems. So I've created some dashboards. Dashboards, who's using dashboards today in CloudWatch? If you're not, use them. They're great. You install, or you actually create some widgets within this dashboard on some of the metrics that you want to see. So let's see. I was doing something on this one in the last 3 hours. Yeah, so I ran a test earlier today. So what this is, I've got a CloudFormation template that will create this this dashboard. It also creates some CloudWatch alarms for burst credit balance. So you can actually monitor your burst credit balance for your file system. And what that allows you to do is if your burst credit balance is starting to drop below, and you can actually, within the CloudFormation template, you identify, I want to be alerted, say, 3 hours before it could fail or it could get to zero. And there's really 2 thresholds, a warning and a critical. You can set that up where it'll actually dynamically, every time the credit balance changes, it'll do another calculation and set that threshold to make sure that you're warned at least 3 hours before it drops to zero. So all that's set up for you within this CloudFormation template, and it's actually included and added to this dashboard. Within this dashboard, you're also looking at throughput and IOPS metrics. So in this environment here, we were running 380 billion bytes per minute. I don't know what that works out to be, but it was around, I don't know how many. That's a lot. It's a lot. It's a gigabytes per second throughput that I was getting when I ran a test earlier today. So again, use CloudWatch dashboards to monitor the throughput, the IOPS, and your burst credit balance of your EFS file system, so you're not caught off guard when you start running low on your burst credit balance. And lastly, actually there's a couple more things on this slide. When you set up an AWS, set up triggers. So you want to make sure, when do we want to scale? Have a scale policy, out and in based on, connection count, CPU. There's a number of different things that you can do in order to identify a scaling policy to actually scale out your auto-scaling fleet. Test your application. Remember, EFS does support, its NFS 4.0 and 4.1 compliant, POSIX permissions. On the database side, Amazon Aurora is MySQL compatible. But again, test out, make sure everything is working correctly. I've been doing a lot of tests with WordPress over the last year. Created this architecture, have run it hundreds of times, done a lot of different configurations. I haven't seen any issues running with Aurora and EFS. Make sure that you monitor your burst credit balance if your file system isn't that large. But I haven't seen any issues. But again, each environment is a little different. So test it out. Make sure that it's working according to your needs. Here are some references. The reference architecture listed here, some of the different web pages for the services that I mentioned and that are included within this reference architecture, as well as information about OP cache and really why you want to take advantage of OP cache when you're accessing, when this data is being accessed from an EFS file system. And then also the W3 Total Cache plugin that you can install, just optional, to really take advantage of some of the other services of AWS within WordPress. CloudFront as an example, or even Elasticache as an example. Or you could even you can create an S3 bucket and put in maybe static content in an S3 bucket and move some of those static content images to S3 as another option. Again, you would have to use a plugin. If you want to maintain a plugin, you could do that as well. So a lot of different options. That's really what we wanted to do with this reference architecture, is give you options so that you're able to, depending on your needs, to be able to take advantage of really anything that we have out there. So that is it. I think that's all the time that we have. I appreciate you coming today. Again, check out our references later on when you can download these slides from SlideShare and test it out. Test out the reference architecture, the CloudFormation templates. Give me feedback. See if there's any things you want to change, add, modify. It's on GitHub, so you can go ahead and branch off and make changes yourself. So again, thank you very much for coming today.